All right, so let's describe an interval notation, all points that satisfy this. Now, again, this has a little bit of a trap in it. You can't just blindly do algebra here, because you've got to be very careful of logarithms. Logarithms, we can't take logarithms of non-positive numbers, right? Log of 0 doesn't make sense because anything to any power is not going to be equal to 0. Anything, certainly 2 to any power is not equal to 0. Same with negatives, right? 2 to any power is always positive. So this easily makes you think the following. You can get lost. So you might say, okay, look, I know that I've got this nice increasing property, or I've got this nice inequality preserving property, so this has to be this. Okay? So then you say to yourself, okay, brilliant, this is exactly the same as x is less than 6, just by taking away 1 from both sides. So then you say to yourself, it's going to be minus infinity to 6. And you'd be right in many ways, but there'd be a big mistake you'd have made. If you're doing this, you're clearly assuming x can be negative, right? And I think we're going to run into problems with negative x here. Right? If I have x2 negative, x plus 1 is going to be negative, and I'm going to be feeding a negative into logarithm. So for this to make any sense whatsoever, we also have to impose the condition that this is true. Now, if that's true, not so bad. Adding minus 1 to both sides will give me a minus 1 here. And now, of course, this tells you x is in the interval minus 1 to 6. So this is quite a good example to keep you on your toes. You don't want to just, as I said, blindly follow the algebra. You want to be super careful about the meaning of what you're dealing with, right? Logarithms, you can't take log of a negative. That must be incorporated into this.